A faint ember drifts into our solar system, a visitor from another star. At first glance, it looks like any comet, a haze, a glow, a wisp of tail. But then the strangeness begins. It breathes carbon dioxide instead of water. Its light scatters in ways no comet has ever shown. And instead of pointing away from the sun, part of its glow points toward it. What kind of traveler does this? Could our very definition of comet be too small for what we are seeing? Tonight, we follow 3E Atlas on its rare journey past our planets. And we ask the deeper question, is this simply another comet, or a messenger forcing us to rewrite what we thought we knew about the universe?
What do we do when something in the sky insists on being familiar, yet every time we measure it, it whispers that it is not what we think? What if the universe placed a traveler in our path that wears the clothing of a comet, but moves with the posture of something else entirely? Welcome, friends, to Velocity of Comets. I'm glad you're here tonight. Together, we will walk into the stillness of the cosmos and meet a visitor whose story may change the way we think about what a comet truly is. Stay with me. This is not just a report. It is a journey we take side by side. Imagine the black ocean of interstellar space, a place so vast that stars themselves seem like grains of dust scattered across an endless canvas. Out of that deep silence, an object approaches. It is small on the scale of worlds, only a handful of kilometers across, yet in significance, it is enormous. Astronomers have given it a simple name, 3I Atlas, the third confirmed interstellar object to enter our solar system. The I stands for interstellar, a reminder that this body was not born under our sun. It belongs to another star, another cradle of worlds, another family of planets we will never see. And now it passes briefly through our skies, offering a fleeting glimpse before vanishing forever into the dark. From the beginning, most scientists have called it a comet. After all, it wears the signs: a faint coma of dust and gas, a subtle tail stretching into space. But the more closely we observe it with our greatest eyes, NASA's Hubble Space Telescope, the James Webb Space Telescope, observatories in Hawaii and Chile, the more this object resists our categories. It shines in ways no comet should. It breathes gases in proportions no comet has ever shown. And it glows at distances where comets should be silent and still. Think about this. A comet from our own solar system usually comes alive when it draws within 3 astronomical units of the sun. Water ice begins to warm, molecules leap into vapor, and sunlight paints a luminous veil around the nucleus. That is the standard story. Yet 3I Atlas was active much farther out, nearly 900 million kilometers away, 5 or 6 times farther than Earth's orbit, where it should have been nothing more than frozen rock and ice. And still it glowed. Still it breathed. How could that be? One answer is that it contains layers rich in carbon dioxide, a volatile that awakens earlier than water. But even that doesn't explain all we see. NASA's James Webb Space Telescope has already pried into its light. Webb found that the gas streaming from this traveler is dominated by carbon dioxide. Water is there, yes, but faint and shy compared to the flood of CO2. That ratio is not just unusual, it is extreme. No comet in our records, not even the bizarre outliers of the Oort cloud, has shown a profile quite like this. If we compare 3I Atlas to the second interstellar comet, 2I Borisov, the difference grows sharper. Borisov was rich in water, behaving more like a comet we would expect, though still exotic. Atlas, by contrast, seems to have been forged in a different furnace, under different rules. And then comes the light itself. Polarization studies, measuring the direction in which sunlight is scattered, reveal that Atlas bends light in a way utterly new. Astronomers at observatories in Europe and Asia have tracked its polarization curve, and the results break every known category. Its negative polarization is deep and narrow, a sharp plunge in the curve where no comet or asteroid has ever gone. To you and me, this means simple wonder. Its dust and grains are arranged or composed in ways that scatter sunlight unlike anything else in our experience. Once again, it looks like a comet, but on closer examination it defies the role. And still there is more. Comets grow tails that stream away from the sun, pushed by the steady hand of solar radiation. But Atlas shows something stranger. A sunward extension, an anti-tail. Normally these are illusions, tricks of perspective, seen only from certain angles. But in this case, the geometry says otherwise. NASA's modeling suggests we are not being fooled by line of sight. What we see is real, a spear of dust pointing toward the sun, a shape so rare that out of thousands of known comets, only a handful have ever displayed anything like it. And never to this degree. It is as if this traveler insists on turning its face into the light instead of away from it. Picture yourself standing on a mountain observatory, the dome above you peeling open to the cold night sky. The telescope hums, gears turning as it follows this faint smudge across the stars. Through the eyepiece, or more truly on the glowing screen of the detector, you see the point of light with its small veil. It could be any comet, but as the data streams in, you begin to notice the fingerprints, the CO₂ lines strong, the H2O lines weak, the polarization curves bending in new directions, the tail that doesn't behave like a tail. You realize you are not just looking at a visitor, you are looking at a messenger from another world, and it is speaking in a dialect we do not yet understand. And there is the paradox. If it quacks like a comet and looks like a comet, do we have the right to keep calling it one when the details shout otherwise? For most of astronomy's history, the rule has been simple. If it behaves roughly comet-like, label it a comet. But what happens when the details stretch that definition so far that the word begins to break? Atlas is that question, made manifest in orbit around the sun. This is where our journey begins. Tonight, I am not here to sell you sensational answers. NASA has been careful and sober. This is not a threat to Earth, not a spacecraft in disguise, not a harbinger of doom. It is a natural object, a body on a predictable path that will never come closer to us than 1.8 astronomical units. The story here is not fear. It is wonder. Wonder at how the universe continues to surprise us. How every new messenger teaches us to expand the walls of our categories. So here is my invitation. Stay with me. Let's follow Atlas across the sky as it swings past Mars in early October, past Venus in November, past Jupiter in March of next year. Let's watch as Webb and Hubble keep their gaze on it, as ground-based telescopes record its changes, as scientists across the globe share data in real time. And together, let's ask the deeper questions. What does this mean about how planetary systems form? What does it tell us about the diversity of ices and rocks that drift between the stars? And most of all, what does it mean for us? That we are living in a moment when visitors from other stars are no longer the stuff of speculation, but of observation. I promise you, if you walk with me through this story, you will see not just a comet, but a new definition of what a comet can be. You will feel the awe of knowing that the universe is bigger, stranger, and more generous with surprises than we ever thought. So subscribe, not just to this channel, but to the journey itself. Because the cosmos will keep sending us these travelers, and I want us to be there, together, ready to greet them with open eyes and open minds. Do you remember the hush we felt as we first looked at 3i Atlas in the opening of this story? That quiet moment in the observatory, when the object looked like any comet, and then, detail by detail, it refused to fit the role. Let's return to that feeling now, but with sharper eyes. We've set the scene. We've asked the paradoxical question. And now we have to confront the evidence in full. This is where the universe asks us to do the harder work. Not just to marvel, but to measure, compare, and test. The James Webb Space Telescope gave us one of the first great surprises. As Atlas approached from interstellar space, Webb turned its infrared eyes toward the tiny coma. What it found was startling. Carbon dioxide pouring out in strength, water trailing far behind. The ratio of CO2 to H2O reached values around 8:1, among the most extreme ever measured in any comet. In a typical solar system comet at this distance from the Sun, about 3 astronomical units, you would expect water to dominate. That is the script. Instead, Atlas spoke a different language. Why? There are 2 major hypotheses. The first is that Atlas is simply different because it was born different. Imagine the disk of gas and dust around another young star, light years away, frozen and silent. In some regions of that disk, carbon dioxide would have condensed before water. If Atlas formed there, its nucleus might be laced with CO2 ice in far greater abundance than what we see in our comets. When sunlight touches it, carbon dioxide wakes up first and floods the coma. In that scenario, the story is simple. Atlas carries the fingerprint of another star's nursery. The second hypothesis is more subtle. It suggests that the nucleus of Atlas has layers, a crust, or perhaps a mantle of dust that hides the water beneath. Sunlight might not yet be reaching the deeper layers where water ice rests. Instead, it is heating pockets of carbon dioxide closer to the surface, making the outgassing seem biased. As the object draws nearer to the Sun, passing perihelion just inside the orbit of Mars, those deeper layers may finally open up, releasing more water and changing the ratio. If this proves true, then what we are seeing is not a different kind of comet, but a comet with a different timing. So far, both of these explanations are possible. Neither one requires fantasy. Neither one demands the impossible. But whichever proves right, the message is clear. Atlas is not playing by the same rules as the comets we grew up with. The next layer of the puzzle lies in the way Atlas scatters light. Astronomers use polarimetry, the study of how light waves oscillate, to measure the properties of dust grains. It's like reading the texture of sandpaper by running your fingers across it. Normally, comets show a predictable curve. The polarization dips slightly negative at small angles, then swings upward to positive values as the angle grows. These patterns are so consistent that comets are grouped into families based on them. But Atlas breaks away. Its polarization curve dives deeper into the negative than any comet on record, and it recovers at a much lower angle. What does this mean? One possibility is that the grains around Atlas are unusually fine, or porous, or coated with exotic ices that scatter sunlight in new ways. Another is that the grains are not arranged in the same balance as those from our Oort cloud. The truth may be a combination, but the conclusion is unshakable. The dust cloud around Atlas is not ordinary. And that is exactly what we should expect from an object born in another star system. For decades, we have known our catalogue of comet properties is provincial, shaped only by what we could see here. Atlas is expanding that catalogue, and doing it in dramatic fashion. Now, let's talk about its shape in space, the tail that does not behave like a tail. Radiation pressure from the Sun normally pushes dust away, forming the familiar streamers of light we see in comets like Halley or Hale-Bopp. But when astronomers imaged Atlas, they saw something extraordinary: a sunward extension, an anti-tail. Out of thousands of comets observed, only a handful have ever displayed such a thing, and none with this clarity. Usually, anti-tails are illusions, a matter of perspective, but calculations show that this time, geometry cannot explain it away. The sunward spear is real. How could that happen? Some models suggest that larger dust grains, less sensitive to radiation pressure, can linger closer to the Sun. If Atlas vents in a way that favors those grains, perhaps through anisotropic jets that fire sunward, then a real anti-tail forms. What looks impossible becomes natural once the physics is clear. And yet, it is still astonishing. This comet bends the ordinary script not by breaking the laws of physics, but by writing new variations on them. There is also the question of early activity. Atlas was glowing and active at distances where water should have been frozen solid, nearly 900 million kilometers away. Again, carbon dioxide offers an explanation. CO2 and carbon monoxide can sublimate at much greater distances than water, sparking activity in comets before water ever wakes. NASA's catalogue contains other examples of CO-driven comets, though none interstellar. So here too the explanation is natural, but still remarkable. The first breath of Atlas was carbon dioxide, not water. That too tells us about the chemistry of its birthplace. Now we come to size. Estimates are tricky because the coma hides the nucleus, but Hubble data suggest that the core may be larger than 2I Borisovs, perhaps several kilometers across. Some early interpretations even placed it tens of kilometers wide. A body this large, plunging through the inner solar system, is statistically rare. If interstellar objects arrive randomly, we should expect to see many smaller ones before such a giant. Yet here it is, the third interstellar visitor we have ever caught, and it may be the biggest. Is that chance, or are our expectations wrong? With only 3 known samples, statistics are weak. We cannot conclude anything yet, but it is another layer of strangeness. And finally, the trajectory. Atlas does not cut randomly across the sky. Its path lies close to the plane of the ecliptic, the flat disk where most of our planets orbit. By pure chance, it will pass near Mars, Venus, and Jupiter, though not Earth. Mars in October, Venus in November, Jupiter in March. These encounters are not dangerous. Atlas will stay more than 1.8 astronomical units from Earth, but the alignments are intriguing. Some call it coincidence, others wonder about purpose. The truth is likely geometry and probability. Yet the sight of an interstellar traveler brushing past 3 planets in a row adds poetry to the puzzle. So where does all of this leave us? With competing hypotheses, with puzzles unresolved, and with debates that cut to the heart of how science works. Some argue that, because Atlas has a coma, a tail, and outgassing, we must call it a comet. Others argue that the differences are so vast that the word breaks down. But this debate itself is a gift. It forces us to test our assumptions, to examine our categories, to refine our definitions. That is how science grows. As we stand here in this moment, watching the data stream in, we have to remember what this really means. For the first time in history, humanity is not just speculating about interstellar travelers. We are observing them, one by one, with instruments capable of dissecting their light. One eye Oumuamua showed us a fragment shaped like no comet we had ever seen. 2I Borisov showed us a comet that looked surprisingly normal, yet came from another star. And now 3I Atlas stands before us. A paradox, a comet that is not quite a comet, behaving in ways that stretch our imagination. The wonder is not that it is strange. The wonder is that we are here, alive in this moment, with telescopes and spacecraft and teams of scientists around the globe, able to measure that strangeness in detail. NASA's Hubble images, JWST spectra, ground-based polarimetry, all woven together into a tapestry of discovery. And while we argue about labels, the truth is larger. This is the universe, reminding us that our categories are temporary, our knowledge provisional, and our curiosity eternal. Stay with me as we continue, because in Part 3, the story rises to its climax. We will gather the threads, confront the astonishments head-on, and ask what they mean for the future of exploration. We will ask not just what Atlas is, but what it teaches us about who we are. Curious beings standing on a small planet, looking out, and finding our definitions stretched by visitors from other stars. There is a moment in every story when the curtain lifts, and the scene takes on a new light. For 3i Atlas, that moment is now. We have lingered in the shadows of analysis, turned the puzzle pieces in our hands, and weighed the evidence. But here, standing at the edge of its journey around the Sun, the strangeness crystallizes into something astonishing. Atlas is not just another comet passing through. It is a revelation of diversity, a messenger from another system, and the reminder of how vast and unexpected the universe really is. Let's gather the truths we cannot ignore. First, Atlas exhales carbon dioxide with an intensity that eclipses its water vapor. That alone is extraordinary. In our solar system, water almost always dominates. But this object shows us that elsewhere, another balance can prevail. Imagine a nursery of planets circling a young star, where CO2 condensed earlier and deeper, embedding itself in the icy cores. Atlas may be a frozen time capsule of that distant environment. To hold that knowledge in our telescopes today is astonishing. We are not just studying ice and dust. We are holding a fragment of another world's history. Second, the light it scatters bends rules we thought were firm. The polarization curve plunges into negatives so deep that no comet we have catalogued can match it. The grains surrounding Atlas are whispering something about their size, their porosity, their chemistry, things that do not match the dust of our Oort cloud or Kuiper belt. And this is the wonder. Nothing has broken. The physics of light scattering still holds. What has changed is our understanding of what dust can be. This is the universe giving us a new ruler, a new way to measure the diversity of materials beyond our system. Third, the anti-tale. Against all intuition, against the familiar images of comets streaming away from the Sun, Atlas points a spear of dust back toward the star itself. This is not an illusion. Models show that certain grains, launched in just the right way, can survive long enough to trace a sunward line. Once again, the laws of physics stand unshaken. It is our assumptions that are humbled. The beauty of this truth is that it takes what seemed impossible and reveals it to be inevitable once we understand. That is the essence of science, the transformation of surprise into comprehension. When we put these revelations together, the climax of the story is not that Atlas is alien in the science fiction sense. It is that Atlas is alien in the most profound way. A child of another star, carrying within it the fingerprint of a planetary nursery we will never see. It is astonishing to realize that right now, this visitor is sweeping through our skies, offering a sample from another system for free. No spacecraft had to fly for centuries. The cosmos delivered it to us. That is the miracle. From this truth flows a wider river. Every interstellar visitor we catch, Oumuamua, Borisov, now Atlas, adds to a new atlas of exocomets. Piece by piece, we are building a comparative science of planetary systems. And this science is still in its infancy. With only 3 examples, we cannot yet map the whole landscape. But each example has shocked us in a different way. Oumuamua was elongated and tumbling, with no visible coma. Borisov looked like a more familiar comet, rich in water, but still carried signatures of a foreign origin. Atlas is stranger still, with CO₂ dominance, polarization anomalies, and an anti-tail. What will the 4th, the 5th, the 10th bring? The only safe prediction is that they will surprise us. Here is where we must expand the circle of meaning. Atlas is not just a scientific case study. It is part of the human story of exploration. When Hubble trains its ancient mirror on this visitor, when Webb unfurls its golden eyes, when polarimeters in Europe and Asia and the Americas sweep the light, humanity is doing something extraordinary. We are collaborating across nations, languages, and disciplines to listen to a single messenger from another star. That unity is a preview of what our future must be if we are to thrive as explorers. Consider the missions on the horizon. ESA's Comet interceptor is designed to wait in space, ready to launch toward the next unpredictable visitor. NASA has studied concepts for rapid response missions that could catch an interstellar object on its way in. SpaceX, with its Starship, is quietly building the heavy lift capacity that could make such missions affordable and fast. Imagine a future where a fleet of interceptors waits at the edge of our solar system, engines ready, prepared to chase down the next traveler. Atlas reminds us why we must build that future. Without preparation, these gifts pass us by, never to return. With preparation, the next one could be ours to touch, sample, and study up close. And what does this mean for the oldest questions of all? Are we alone? Are planetary systems like ours the rule or the exception? Atlas does not answer directly, but it tilts the scales. It shows us that the chemistry of other systems can be radically different, that carbon dioxide can dominate, that dust can scatter light in alien ways. If planets formed around Atlas's star, they would have carried these differences into their own atmospheres, surfaces, and oceans. Some might have been worlds where carbon dioxide ice was as abundant as water is here. Would life be possible there? Perhaps. Would it look like us? Almost certainly not. Atlas doesn't close the question. It makes the question larger. I feel a deep awe in knowing that we are here to see this. For most of human history, we looked at comets as omens, as mysterious streaks that came and went. Today, we can measure their chemistry across billions of kilometers. We can argue about the ratios of carbon dioxide to water, the angle of polarization curves, the survival of dust grains in sunlight. That is progress of the most profound kind. And yet, it does not diminish the awe. If anything, it deepens it. The more we understand, the more miraculous the universe becomes. As Atlas swings past perihelion, inside the orbit of Mars, the story is still unfinished. Will water surge and balance the ratio? Will the polarization curve shift as the coma evolves? Will the anti-tail grow sharper or fade away? These are questions we will answer in real time, together, through the eyes of our telescopes and the voices of our scientists. It is a reminder that discovery is not a finished product, but a living process, unfolding night by night. So here is the larger truth. Atlas is not just telling us about itself. It is telling us about us. It is reminding us that our categories are temporary, our definitions flexible, our understanding incomplete. It is teaching us humility, the kind of humility that is not weakness, but strength, for humility is the doorway to wonder. Without it, we cling to labels that break under pressure. With it, we let the universe expand our minds. And perhaps that is the greatest gift of this interstellar visitor. Not just the data, not just the papers and graphs and models, but the reminder that we live in a universe that is bigger than our imagination. A universe that continues to send us mysteries not to frighten us, but to invite us deeper. A universe where, from time to time, a messenger from another star swings by, asking only that we pay attention. So, as 3i Atlas fades into the dark, remember this moment. Remember that you were alive when humanity first began to build its atlas of interstellar comets. Remember that you were here when we asked not just what this object is,
Sex 0.05, but what it means for us as explorers, as thinkers, as a species just beginning to stretch its gaze beyond its home star. The future will hold more visitors. The future will hold more surprises. And if we walk together, open-eyed and open-hearted, we will be ready.
As our journey with 3i Atlas draws to a close, let's pause to gather what it has shown us. We began with a visitor that looked like a comet, but refused to behave like one. We followed the trail of evidence, the overwhelming breath of carbon dioxide, compared to the faintest whisper of water. The light that bent polarization curves into uncharted territory, and the defiant anti-tail that stretched toward the sun. Each of these alone would have been remarkable. Together, they paint a portrait unlike any comet in our solar system. What does that mean? It means we are expanding the boundaries of our understanding. It means that comets, especially those from other stars, will not all fit into neat boxes built from our limited experience. Atlas may not be rewriting physics, but it is rewriting us, forcing us to accept a wider range of possibilities, to let the universe surprise us, instead of shrinking it to fit our categories. I feel something deeply human in this moment. For centuries, comets were feared as omens. Tonight, we see them as teachers. And Atlas, in all its strangeness, teaches us humility and wonder at once. Humility, because it reminds us that our knowledge is provisional, always open to revision. Wonder, because it shows us how astonishingly diverse the universe really is. So let me leave you with a simple question. Which part of Atlas stirs your imagination most? Its chemistry, its light, or its path across the planets? Share your thoughts, because these questions are not mine alone. They belong to all of us. And if you felt the same wonder I did tonight, subscribe so we can keep walking this road together. There will be more travelers from other stars, and when they come, I want us to be ready, not with fear, but with curiosity.